In this video, we were covering graphing linear equations. So we have some terminology to introduce us to the topic. So a linear equation is just an equation whose graph is a straight line. An x-intercept is the x value at which a graph cuts the x-axis. The y-intercept is the y value at which a graph cuts the y-axis. A relationship between two variables, such as x and y, whose graph is a straight line, is called a linear relationship. An example of this is y equals x plus 2, and this is known as a linear equation. A table of values can be used to find a range of coordinates, which we then use to graph a linear equation. When creating a table of values, you select the x values, you control them. These are then substituted into the equation to find the y values. Any number of x values can be used. In the example on the screen, you can see we have -1, 0, 1, 2. These can change. To find our y values, we substitute our known x values into the equation. So our equation was y equals x plus 3. We now substitute x in -1 in for x, so we get y equals -1 plus 3 equals 2. We then put that value for y in our table of values. You do this until you complete your table of values and then plot each coordinate. We can also graph lines using the x and y intercepts. Remember, the x-intercept occurs where the line crosses the x-axis. To find the x-intercept, we substitute y equals 0 and solve the equation. The y-intercept occurs where the line crosses the y-axis. To find the y-intercept, we substitute x equals 0 and solve the equation. We can also test if a point lies on the line by substituting its coordinates into the equation. If it makes sense, then it is on the line. If it doesn't, it's not. You will see this in an example later. On the screen, we have an equation, y equals x minus 3. We need to graph the following equation on a number plane. For this example, I'm going to use a table of values. To start with, I'm going to write down our equation first. Next is I'm going to substitute our first x value in it, which is our -2. So I can now write -5 in the y bracket, in the y slot. We continue this until our table's full. For example, in the next one, we would have y equals -1 take away 3 is -4. Over here, y equals 0 take away 3 is -3. At this point, you can start to see a pattern forming, so I can write the rest of the table out. Once you have that, we can draw out coordinates on our number plane and plot a line. To do this, I will be using a red color to indicate my points. So the first point was x equals -2. And then y equals -5, so I can put a point at that coordinate. -1, -4. I continue to plot my coordinates on until I've plotted them. I can then use a ruler to draw a line through. Once your line is drawn through, that is the equation of the line. That is our graph. Graph the following linear equation after finding its intercepts. So remember, your x-intercept occurs when y is 0, and your y-intercept occurs when x is 0. I like to solve these problems in two columns. Firstly, we're going to find our x-intercept. So y equals 3x minus 6. We substitute 0 in for y, and we have a regular equation, which we can solve. By plussing 6 to both sides, we get 6 equals 3x, and then we can divide by 3. So x equals 2. We do the same for the y-intercept. I write down the equation first, and then I substitute 0 in for x. Notice with linear equations, our y-intercept is always our constant, or the number by itself in the equation. So we have an x-intercept at 2 and a y-intercept at -6. I can now plot these. Unfortunately, our graph doesn't go to -6, so it will be here, and we have an x-intercept of 2. To finish the line, we draw a line connecting the two dots. Next, we're going to test whether the point 3, -1 lies on the line. To do this, we substitute in our values. Remember, this is our x, this is our y. So if I have y equals 2x minus 7, I am then changing the y to -1, and I'll change the x to 3. We end up with -1 equals -1. Since -1 does in fact equal -1, we know that the point lies on the line. Here we have another one. X minus y equals 4. Remember, x was 3, y was -1. So we have 4 does equal 4, the point is on the line. If we ended up with an answer such as 6 equals 4, that doesn't equal 4. Therefore, you would state that the point is not on the line. To end this video, we'll do a quick recap. Remember, a relationship between two variables such as x and y whose graph is a straight line is called a linear relationship. When we want to graph a linear equation, there's two methods. You can use a table of values, or you can use the x and y intercepts. Whichever method you prefer, you can use. It is a good idea to know both in case the question is very specific and has you to do one, not the other. Testing if a point lies on the line means you substitute in your x and y coordinates to test if it satisfies the equation, whereas you have both sides of the equal sign equal the same thing. Example, 4 equals 4.